Okay, in this video, I'm going to show the other part of this theorem, which is if the line integral of f over every closed curve is equal to 0, this implies that f is path independent. So in other words, given a point here and a point here and a path going from this point to that point, let's say with that orientation, and another one again with that orientation, so they're both starting at the same point and ending at the same point, what I need to do is to show that both of the line integrals f over both of those curves is equal to 0. So we've got two arbitrary points and two arbitrary curves between those points. We're just going to show that the line integral of f over the top curve is equal to the line integral of f over the bottom curve. And sticking, I think, with the notation that I used in the last video, I'm going to call this line, this path C1. I think I call it C1. I'll call this path C1 and try to use purple. Oh, hey. And I'm going to call the top path C2 and try to use blue. Okay, so the thing that we know is that the line integral of f over every closed path is equal to 0. So now I'm basically going to make the opposite argument that I made in the previous video. So if C is equal, let me use orange. C is equal to C1 union minus C2. So what I mean by that, we start at this point here, go along C1 in that direction, and now we go along minus C2, which remember is just C2 with the opposite orientation. So C2 and minus C2 are the same path, just with different orientation. So C1 is equal to the C1 is equal to the union of C1 and minus C2. So what does this tell us? The line integral of f over C is equal to the line integral of f over C1 plus the line integral of f over minus C2. Okay, so now what can we do here? Well, what is the assumption? Our assumption is that the line integral of f over every closed path is equal to 0, but C is a closed path. So this is equal to 0. And what we can conclude then is that the line integral of f over C1 is equal to the line integral, is equal to minus the line integral f of f over minus C2. But a similar thing, or the same exact thing from what we said in the last video, this is just equal to the line integral of f over C2. So in other words, the line integral of f over C1 is equal to the line integral of f over C2. The starting and ending points, in other words, this point and that point were arbitrary, and then the paths between them were arbitrary. So what this means is that for any 2 points, the only thing that matters as far as the line integrals go is the starting point and ending point, not the curves between them, or not the actual curve that connects them. And that's exactly what it means to be path independent.